Welcome back to our next session. In this session, we are going to do the problems related to refraction of light at curved surfaces. Previously, in previous two videos, we discussed about reflection of light at curved surfaces problems and sign conventions related to mirrors. In this session also, before we start problems, and I will let you know about sign conventions to be applied to do the problems, okay, of refraction of light at curved surfaces, that is in case of both concave and convex lenses. Okay, now sign conventions to be used while doing the problems related to convex and concave lenses. Okay, so for convex lens, we know convex lens is this is a symbol for convex lens, and this is a lens. Convex lens is a converging lens. Okay, in case of convex lens, now this is what called as a optic center, and this is what called as a focus. If I take this one as f2, and this is a 2f2 or c2, and this is f1, and here it is 2f1 or c1. Now, while writing the conventions, first of all, we should know about a focal length. Focal length in terms of convex lens is always positive. Focal length is positive because in most of the cases, okay, the real images are formed in convex lens. Not only that, even the refracted light rays are going to converge at focus, and we are going to measure the distance of the focus from the optic center to the focus. Okay, and the distance is measured in the direction of the light, hence it is almost we can say considered as a positive value. The focal length of a convex lens is a positive, and the object distance, this is a focal length small f, and object distance is negative, and next one is image distance. Image distance is a positive. Most of the cases, in only one case, okay, that is if the image so formed is virtual, in that case the image distance is a negative. That is when this negative value will come for image distance in case of convex lens means if the object is placed between f2 and O. Okay, in some books it may be f1. Okay, f2 and O. If you place the object between f2 and O, that is focus and as well as a optic center, then the image so formed will be virtual. So in case of virtual image, okay, while you are using convex lens, if the image is virtual, then the image distance will be taken as a negative value. I hope you understood. Okay, now this is about sign conventions to be applied in terms of a convex lens. So then what about this concave lens, sir? Concave lens. Now we'll talk about concave lens. Sir, you did not explain about height of the image, height of the object, vagera vagera. Height of the object will be always on the principal axis. So if I place one object like candle here, so we are going to measure the height of this object from bottom to top in upward direction above the principal axis. That is, object distance will be always positive, and image distance will be negative if the image is real inverted. Okay, and the image distance will be image height will be negative if the image is virtual. It will become negative if the image is a virtual. I hope you all are understanding. So focal length in case of convex lens is a positive, is always a positive. Object distance will be negative always. Image distance will be positive in most of the cases. In only one case, that is if the image is virtual, then in that case only the image distance will be negative. Next, height of the object will be positive, and height of the image will be negative, that is if the image is real inverted, that is image is below the principal axis, okay, and the image is on the principal axis, that is above the principal axis, that to be if the image is virtual, then only the image height will be considered as a what? Positive value. I hope you understood the conventions to be applied for convex lens. Next, I'll be talking about concave lens. So, in case of a concave lens, now if I explain about concave lens, you know well, concave lens is a diverging lens because when the light rays passes through the concave lens, after refraction, the light ray will diverge. Now, this is a concave lens and the symbol of the concave lens is this one, and this is optic center, and this is optic center, and this is, if I say F1, it will become a 2F1 or C1, and this is a F2, and this is a 2F2 or C2. Okay. Now, in case of concave lens, the focal length will be negative, object distance will be negative, image distance will be always negative, and next one is height of the object is positive, and even the height of the image is also positive. Okay, height of the image is also positive because image is virtual, erect, it is always on the principal axis, not below the principal axis, above the principal axis, that is on the principal axis. Hence, image height will be always positive, object height will be always positive, and the focal length will be negative. Next one is image distance. Image distance will be negative, object distance is also negative. Okay. So, these are the conventions which we have to apply to do the problems. I hope you all understood. Now, we'll do the problems related to lenses. First problem is, it is related to convex lens. See, a convex lens has a focal length of 15 centimeter. At what distance should the object from the lens be placed? Okay, so that it forms an image at 10 centimeter from the lens. Also, find the magnification produced by the lens. Before we start doing this problem, we should have idea about lens formula and magnification formula in terms of lenses. Whether it is a concave lens or a convex lens, the lens formula will be 1 by f is equal to 1 by v minus 1 by u. You know well, here f is nothing but what? Focal length, and v is what? Image distance, and u is what? Object distance. Now, if you remember that conventions what I explained before, the focal length, sign conventions for focal length, convex lens na focal length sign convention is positive, and object distance convention is negative, object distance is negative, and image distance will be positive, that is if the image is real inverted. No need to write inverted, if it is real it is a positive because other side of the lens. Now, if the image is virtual, then the image distance will become a negative. Okay, if it is virtual, then the image distance will become a negative value, this is a minus v. Understood? Now, one more formula, that is magnification. The formula for finding out the magnification, okay, in terms of lenses is m is equal to height of the image by height of the object, one formula, and in terms of distances, the formula is m is equal to v by u. In mirror, we saw minus v by u. Here in case of lenses, it is only v by u. You know what is v, what is u, what is hi. Hi means height of the image, ho means height of the object. So, by using these two formulae, we can complete the problem. Okay, now let's see the data given and what is the way how to do the problem. Next, see, now read out once again. A convex lens has a focal length of 15 centimeter. At what distance should the object from the lens be placed so that it forms an image at 10 centimeter from the lens? Also find the magnification produced by the lens. Now in this case, first I will write the data. Focal length f is equal to 15 centimeter. Now if I apply the convention, there is a focal length for convex lens is a positive. At what distance should the object from the lens be placed so that it forms an image at 10 centimeter distance? Okay, now image distance is 10 centimeter. Okay, image distance is 10 centimeter. Now you have to find out object distance. How much? Okay, now we have to use the lens formula. 1 by f is equal to 1 by v minus 1 by u. Use this. 1 by f is nothing but 1 by 15 is equal to 1 by. So v was given as 10 centimeter. V was given as 10 centimeter and u was not given. You have to find out. It will become that is a negative value. Some basic idea you need to think. F is 15, image distance is 10 centimeter, focal length is 15, image distance is 10 centimeter. Then we need to think, we should have some basic idea. Oh, the image so formed will be optic center of the lens and as well as a focal length. It may be virtual image. So hence, by predicting that, I wrote as a minus value for what? Image distance. Now I have to find out the object distance. 1 by v minus 1 by u. V is, we have to write minus 10 minus 1 by u. Now 1 by 15. Bring this one this side. It will become 10 is equal to minus 1 by u. Now LCM. How much will be the LCM? Now, if you want to know about it, how to do, even the students who are little bit dull, okay, I will write 5 1 ja, 5 3 ja, 5 2 ja, 5 3 ja 15, 15 2 ja 30. That is 30 will be the LCM. Now 15 will go in 30 2 times, that is 2 plus 10 will go 3 times, that is 3, that is equal to 5 by 30 is equal to minus 1 by u. Now I will write reciprocal 30 by 5 is equal to minus u. 5 1 ja, 5 6 ja, u is equal to minus 6. Okay, now I will write here u is equal to minus u, nothing but, okay, u is equal to minus 6 centimeter. Okay, we found what distance? Image distance we found. Then what is this magnification? How to do? Now we got image distance is equal to minus 6 centimeter. Sorry, object distance is minus 6 centimeter. Okay, so object distance is minus 6 centimeter you got. Now you have to find out magnification. Magnification produced. Magnification formula. M is equal to minus V by U. Oh, not minus V by U. This is a M is equal to V by U. Now M is equal to V is how much? Minus 10. U is how much? Minus 6. Okay, gets cancelled. I hope you all understood. Now M is equal to 10 by 6. 10 will go. Okay, in 10, 6 will go. One time 1.4. That is 1.6. 1.6 is a magnification. I think you will get 1.666 like that, 6 bar. This is a magnification value. Like my explanation, please comment and subscribe to my channel for more videos.